All right. Welcome to my talk, Distributed Workloads. Hopefully everyone is kind of hungover, so it'll be easier for me to kind of be on the same level as you guys. All right. So my name is Helgi. I'm that handsome guy there in the corner. So I co-founded Orchestra.io. It's a PHP platform as a service. The company got bought by Engine Yards, and we're sponsoring the unconference upstairs, where I'm a software engineer, basically making things scale, kind of to complement what the previous guy was saying. I'm a paired developer. It's an open source kind of effort for PHP libraries. I'm from Iceland originally, and if you want to heckle me during the talk, just @H on Twitter. And if you guys have any questions during the talk, just raise your hand, tell me I'm an idiot, tell me what you guys think, just don't be shy asking shit. Already one person? All right, so why distribute? Why should we create a distributed application? To me, through the years, I've been working with kind of different companies. I had a consulting business before I started the hosting business. And I had to work with a lot of different companies, small, big, all the different types, startups. And we found out that buying your own hardware, or even go for like a VPS or kind of racked solution, was not really cost effective. And so I came up with 3 different things that are kind of like how I think about why we should distribute our workloads, why we should actually use that concept a bit more than we used to. God damn it. See, it's a hangover. So it's the efficiency, it's budgeting, and perception. So what you get by distributing is a lot of different things, and I'm going to walk through each one of them. Can I explain why I think these are kind of the pivotal things when it comes to why you should distribute? It's the efficiency. It's back in the day, a lot of people would buy one big server for their projects. I'm going to start a company. I'm going to buy one single server, or maybe two servers, and I'm going to make them work. In the last couple of years, we've started making a lot more complex software. It's not just PHP spitting out an HTML file and going, hey, here's your forum result, or here's the news website that you just developed. Things are getting really, really expensive and really, really complex. So what I found is, if you take EC2 as an example, using 10 smaller servers, micro, small, medium, and creating like a cluster became more cost effective and allowed me to process more data at the same time. So if we take, for example, image processing, it was quicker for me to do it through multiple small servers. And a lot of people will ask, why? Why is that? It's kind of a Unix restriction in many ways, unless you really know how to tweak your operating system. There's an I/O limitation, both the actual input data, the network data coming into the machine, and then actually processing things on the box itself. So having multiple smaller servers will allow you to kind of balance that out a little bit better. And it allows you to have multiple endpoints, opposed to one that could fail. So that's the efficiency that I've noticed through the years, is to go for multiple smaller servers. And I'm not the only person I've noticed this. If you look at how Facebook or Google actually structure their operations, is that they have throwaway boxes, commodity hardware. And that kind of comes into the next thing, is that most companies don't have a heck of a lot of money. They want to spend the money on developers. They want to spend the money on marketing. So they need to spend wisely. So when you think about my previous slide, when you have 10 small servers, those 10 small servers will actually cost you less than one big one. So like I said, Facebook and Google actually, they buy commodity hardware, throw them into the racks, and when it breaks, I'll just go to PC World and buy more. So it's that kind of concept where you just have to think of servers as a throwaway thing. They're cheap. You don't really need more. You just buy more of them. So that's where EC2 has kind of helped us get into that mindset. You don't always have to buy the most expensive thing out there. Go 10 years back, and if you wanted to start a new product, you actually had to get millions of pounds just to buy hardware. Or you had to lease it from someone else for a high cost, whereas now you can actually just spin up machines on Amazon, boom, everything works, and you get to do it for $100 a month, $200 a month to run your product. And this is actually the reason why we started Orchestra, the platform as a service, is that we had all these startup customers that were telling us, we don't have money to buy servers. We don't have money to spend on servers. You just have money to spend on development. So we thought to ourselves, well, we're having to set up multiple servers for multiple people, maintaining all that stuff. So we decided to kind of take it down to a level where it would be really easy for startups to kind of just go to us, buy our service for cheap, and we will build on top all of this stuff. So that's kind of where we're getting with Amazon these days. And the perception is actually probably the most interesting bit when it comes to distributed workloads. Why? You actually get to defer intensive processing. So I give instant feedback, and I think the best example of that would be, one of the best is Flickr, for example. You upload hundreds and hundreds of images in one go. If you are familiar with the open source photo gallery called Gallery in PHP, what you would do was you would upload an image, and it would start trying to convert the image, resize it, and make multiple copies for you on the fly. So if you actually killed the request, it would, well, die. And it meant that you were having a request going on for many minutes, like sometimes 2, 3, 4 minutes for one photo. So deferring, giving the perception of performance is quite important. It means that you can, on Flickr, you will upload 20 images at the same time, and boom, you'll get instant feedback. Thanks for uploading. We're actually processing this. Within the next 10 minutes, we'll come back and tell you, you're done. But you can keep on browsing the website, which is the most important bit. You can let people keep on doing their stuff, and they're not leaving your website. They can do other things while your heavy operation is going on the side. So it's kind of like, it's lying to people. It's making the goldfish look like a shark, right? A lot of small servers, tiny, tiny servers, coupled together they look like a shark. But in reality, they aren't. They're just, they're Legos. You're building something out of them. Any questions? Any comments? Does it make sense? No? Yes? You guys are asleep, I swear. It is kind of warm in here. All right, so I was watching National Geographic a few months back, and it happened to be an ant show. They were talking about ants. And the more I watched it, the more I realized this is their ants are the kind of the nature's way of going distributed. When they're faced with a problem, those millions and millions of ants in one colony, they will solve the problem as one, right? And that is the exact thing we're doing with distributed workloads, or distributing in general. So what they do, oh, there's a food source on the other side. All right, let's just make a bridge out of us. We're solving a problem together. We dropped into our water, they'll make a floating device out of themselves, and no one dies. So it's the concept of coming together. Georgia Tech actually proved this by dropping them into water and seeing that no one died. So, oops, sorry. So architect for distribution. This is kind of a concept where often when you get a new project, you will start architecting, and you'll sometimes go, when I get this big problem, I will deal with that when it comes. But that sometimes means that you're actually rewriting your system a few times, because you're getting different problems coming in over a period of time. So sometimes you have to think up front, without going too deep into it, how can I architect my product so I can actually anticipate some of the issues that I'll face further down the line. So, what I was going to say? Yes, it requires a little bit of foresight. So the characteristics of properly architected system is that it's decoupled, it's elastic, it's high available, and it has concurrency. So these are the kind of 4 things that you can think about. All right, I'm building a system that potentially is going to go big in a few months. I should probably be thinking about these things in one way or another. Even if you're just thinking about them is enough, you don't have to actually develop for them right away. So, and I'm going to go into each one of them and why they're kind of important and how they can help you further down the line. Even if you implement only one of these, it will help you greatly. So if we go into decoupling, decoupling is taking a whole inclusive object and splitting it up into more discrete objects that can interface together and work together. So it's kind of like the OO concept of things, object-oriented programming, where you actually split things up and then it will all work together as a unison. And for that, I decided to create a little fun diagram, I guess. So this is the traditional application. I guess I do have a laser. So if you look here, this is a single application. This is what most people will develop. This is a single server application. Everything lives on the same box. The API, database, the front end, and the caching layer. The caching being memcache or similar. Front end being like all the JavaScript, all the HTML, and whatnot. So when you need to decouple, you kind of have to start thinking about how can I break up the application so it's not so tightly, inclusive, I guess, or coupled together. Yay. So what I usually do is that I will spin up boxes for each one of these. But you don't really have to do that. It's just the concept of not tying them together so hard-coded in many ways. So you'll end up with the API being its own discrete object, the caching layer being its own discrete object, feeding into the application, and the application just becomes a really light glue to make it all come together and then feed into another. So like the front end here, the application could be building the database and the caching for the API or the front end. They're just kind of like outputs. So in that example, what happens if we're the next Twitter, right? It would be pretty easy to just spin up, in this case, a new caching server. No problem. Our caching server was being overloaded. We'll just spin up a new box. So decoupling gives us the ability to just go ahead and, this is owned by a different team. They're responsible for it. It's like separation of responsibility. And so instead of spinning up a completely new box with everything duplicated on it, you just spin up a new caching layer. So now you have 2 boxes. And then suddenly, like Twitter famously kept having their API going down, in this scenario, you can just go, hey, I just need a new API box because the API is being hit really heavily, but everything else is chugging along just fine, no problems. Well, let's just not add another one. We get even more traffic. It's just that kind of approach to development where everything becomes the discrete components. And that's where elastic behavior actually starts feeding into things. Elastic behavior is the ability to kind of bring things up and down really quickly. And it's really, you can't do that without decoupling your application in many ways. With elastic behavior, it means that I can spin up 10 new boxes in the next 2 minutes to deal with a load. And within 2 minutes after that, when the load goes down, I can just spin them back down. And most of the application is no wiser about it. It's just a thing. It pops up, deals with loads, and then you shut them down. You don't need them after that. This is where, EC2 kind of excels, because it becomes really easy to throw away things or add things. It gives you power. This is why I kind of like working as a sysadmin these days, opposed to a full-fledged developer, is that I get to play with these kind of low-level things, where I'm getting to build systems that can kind of expand and contract like an elastic band, which is really fun. A I think the most important part of elastic behavior is the fact that you can shut down resources. It's the ability to cut away things that you don't need anymore. And that is not possible when you have your own big, huge box. You realize, oh, I actually don't need that huge box. What am I going to do? Now I have extra capacity. It becomes a bit of a conundrum dealing with management at that point. Well, cloud computing, like I've said before, they have kind of given us the way forward in many ways. They allow us to do things on the cheap without having to worry about cost too much. And like I said before, that's why Facebook started buying their own small servers to throw in, like cheaper servers. Any questions? Any comments? You guys really need to say something. I feel like I'm alone up here. All right. So when you're dealing with elastic behavior or you start decoupling things, then it becomes kind of obvious that you kind of have to start load balancing. Load balancing is the way of, you hit a single endpoint, it will fan out the requests to different boxes. So if you have a load balancer in front of the API, it doesn't really matter how many boxes you bring up or bring down. The load balancer is the one that will go, I know what's happening. I know how to actually send you to the right boxes within the API. Oh, this box has no traffic, so all the next traffic will go there. But load balancers start to become a single point of failure. I've gotten this question a few times. If you're creating your architecture in a way where everything is decoupled, you can bring everything up and down, how do you make sure that the load balancers don't die? But it's one of these things where it's really hard to not have a single point of failure in your system somewhere. If it's not the load balancers, if I load balance the load balancers, or I start doing some tricks, I can start doing DNS tricks. One single DNS record can have multiple endpoints. You can have actually, sorry? Thought it was a question. So you can have multiple DNS records for the API, which points to multiple load balancers. So when one load balancer dies, you can have a short time to live on the DNS record and really quickly remove that entry. But you kind of have to do that by hand. So it becomes a bit kind of annoying thing. But with load balancers, it allows us to, so elastic behavior is a concept that load balancers facilitate. So they will allow you to go from 40 requests, if you have boxes that take 40 requests a second, right? You have a heavy application on a single box. You can throw 20 boxes behind that, and you go up to, boom, 600 requests a second just by putting a load balancer in front of 20 machines. And you can also, upgrading becomes really easy actually as well. You can put cookies so people go to specific servers, and then you're spinning things down on the side. So you make sure that people are only going to the older servers for a while, and then as soon as the upgrade is done, you start moving people over behind the load balancer. So my favorite load balancing tools are HA Proxy and Nginx. HA Proxy is a specific load balancing tool, or a proxy, if you like, where Nginx is actually a web server that can do proxying and load balancing as well. It's quite powerful. Go for it.
Okay, so excuse my ignorance, but your load balancer is distributing things out to web servers that have low traffic, etc. That makes sense. But what your load balancer is kind of like the single point of entry. So what kind of a machine do you need to manage shitloads of load that's coming in, right? Do you have multiple? I mean, like, because it always has to end at one. Right? Yeah. Am I correct?
Right.
So what do you do? Is that the one machine that you just got to beef up?
Yeah, so the question was, if all the machines are smaller, all the web servers and whatnot, but the load balancer is the only one that gets all the traffic, is that the only machine you need to beef up? So yes, in many cases, that is the machine that you need to beef up. If you go for Amazon, you can just use their load balancers, so you don't have to care about it. But the thing is about load balancers, though, is that you can beef them up, but because it's only a pass-through, it's actually not processing anything. You can actually get away with, keeping one load balancer that can handle 2,000 requests, and then the 20 machines behind it can only handle 600. So the load balancer itself becomes less of an issue. But you can also just have multiple smaller load balancers that own a pool of other servers as such, and use the DNS trick to kind of use the DNS records to fan that out. So you can cheat the system if you like, but you can also use like a hardware load balancer, or there's ways to do it. But the load balancers end up being the beefy bit in the system, but they're also a fairly constant thing. They're just passing along traffic. So if you want to update the PHP version, you don't have to care about the load balancer, but you have to be able to upgrade the web servers and deal with all that stuff. You want to roll out the new version of your application, you want to roll out the new version of your API, you want to start using Mongo instead of MySQL, all that kind of stuff. The load balancer doesn't care about that, but you have to deal with that internally. So the load balancer kind of gives you, it's just like a gateway, hides all the mess from the users kind of thing. It gives you a lot of power with upgrading, basically, as well as obviously load balancing out the loads. So it's a twofold thing, but yeah, basically.
Not so much a question, more of a comment.
Okay.
DNS TCLs not really good when doing this. ISPs don't have to respect TCL. You never fix stuff.
That's true.
So you could have a 30-second timeout and the users.
Well, yeah. So the statement was ISPs will not have, they will not always respect the time to live on the DNS record. So it's a bit of a sketchy way to do it. It's a hack. Yeah, you could do that as well. That's actually a good point. I had that in my notes, but I didn't say that. And thanks for reminding me. You can actually, so he was saying that you can use virtual IPs, which is the same concept if you use Amazon and they have elastic IPs. It's just virtual. You can switch the hardware behind it without a problem, and you're just always pointing to that single location. So, for example, let's see, 3 days ago, I was doing some upgrades to our orchestra infrastructure, just a small bit of it, but we were switching out boxes, and we thought we had everything solid up and running. And we used one of these virtual IPs to actually, so our DNS record points to that virtual IP, and then we just switched. Things went horribly wrong, and it just took us a second to switch back. So virtual IPs are actually really powerful. It is interesting to set them up, especially when you're combining it with heartbeat systems and whatnot. You're getting kind of low level at that point, and you need people that really know what they're doing to help with that, or use Amazon for that. But it's a really good point. Those actually could potentially solve that DNS problem. Thanks. There was a question over there.
So you said these are your favourite. Is that in a case where you have an instance running, you get a virtual instance and you install those and use those for load balancers rather than cloud service or hardware?
So these are my favorites because I don't always have access to hardware load balancers. They're expensive. To use the Amazon load balancers, I usually use those, but there are cases where people want to use something that is not, cloud specific. They want to use something cloud agnostic. So yes, if I don't have access to like these kind of prepared services or hardware, I would go for these, install those myself, and manage that out from there. It's kind of depends on what kind of product you're building and how much you want to rely on Amazon, for example. Even if you're building on top of Amazon, do you really, really want to be building on, really buy into all their technologies or not? So it just becomes a question at that point. How heavily do you want to buy in?
You have to build the most reliable solution when you go with the Amazon solution.
Right now?
Yeah.
Yes. Oh, no, sorry. If I had all the money in the world, I would buy hardware load balancers and, do all that kind of hardware stuff that you can do. But if I have, some money constraint and I need to make a really good system, right now I would go for Amazon, definitely. And within Orchestra, we use the Elastic load balancers, we use the Elastic IPs, we use a lot of their infrastructure to kind of complement our own stuff. So we don't have to be, we don't have to hire 300 people just to manage our infrastructure. But the reality is that, we may not always be on Amazon. So we already bought into the infrastructure so heavily that now we're stepping back and going, well, what if we want to buy our own hardware? What now? Now we're so reliant on them. So it's that kind of, you need to make that decision where you want to actually sit with that.
What's your view on services like right scale, sort of abstract which clouds you use so you can switch, so to speak? Or
Right scale.
of course you need money for that.
Yes, right scale is a solution that can move you between clouds and all that, but they're really expensive. I don't have experience with that, but anyone that I've talked to either goes, they're amazing, or they really, really suck. It's like, I've never seen anyone go like, yeah, they're okay. It's either spectrum. But they are a solution to, right scale is a solution to be multi-cloud or move between, but I'm not sure how good they are. All right, let's continue, since we only have 20 minutes left. Monitoring. Like a man over here said, the heartbeat monitoring on your IPs is really important, but monitoring and heartbeat in general is really important in your system when you're designing a system like this. So if you have the decoupling, you have the elastic behavior, you have the load balancers, that only gives you so much. But now we need to actually start thinking about monitoring. It's a really essential tool because it will tell you when to actually move up or down. Otherwise, you're just guessing. Like, I think this is slow, let's add something. Oh, this is fast, let's remove a server. You don't really want to be doing that. So it tells you when you will need more servers. And the reality is it needs to be there from the start. Keep the records. Why? You want to be able to spot trends over time. It's kind of one of these things. You can actually start merging your records as you go along and say, for the last year, I only want to have like a 5-minute incremental view of my servers. But for the last day, I want to have like to the second updated version of my traffic. So, but you need to keep the records to kind of realize how you've been doing, why you've made these decisions, and so on. So there are different types of monitoring. So availability would be a heartbeats monitoring solution, hardware performance, software performance. So the software performance would be, how is my PHP application doing? How is Nginx doing? What's the story there? Hardware performance is like CPU, memory, I/O, network, that kind of stuff. So you need to know all these things to couple it together. You can look at the PHP performance and go, why is my application so slow? And then you actually look at the hardware performance metrics and go, well, my server is not actually doing anything. It's just doing nothing. It's just sitting there. And then oh, okay, so it's my PHP thing that's broken. It's like stuck in a loop somewhere, but actually not eating up things. It's just blocking. And then you have to start thinking about, what kind of monitoring solutions am I going to use? One of my favorite ones is New Relic. In fairness, they are one of my company's add-ons. So I might be biased, but New Relic is a really, really nice monitoring solution. Why? Because they don't just do PHP. They do loads of different things, and they actually give you a real insight into what's happening in your PHP application. It's kind of like if you think about Xdebug and XHprof combined with some more metrics that can give you like a real dig into what's happening on your servers. And you just install a PHP extension on your server, it will feed back to their centralized whatever, and you can just go on and say, oh, I have 10 servers. Show me the metrics for each one or the aggregate of all of them. So it's really interesting. CloudKick is another one. Rackspace actually recently bought them. They will give you a 3D view of your infrastructure. It's really crazy. Really cool though. They give similar metrics. You install something on the box, and you feed that up there, and they'll go, oh shit, something's happening. Scout app, if you don't really want to pay money, it's fairly cheap. There's old school Nagios, Cacti, and a really cool one made by OmniTI, Circonis. It's a really cool solution where you can actually start building your own graphs. It sucks in all the data into a centralized Postgres server, and then you can just drag and drop things into a graph, and like, oh, this is like a great view for my manager to look at to see how well I'm doing. I want to get that 2,000 pound promotion or 20,000 pound promotion because I make pretty graphs that make it look like I saved us money. I may or may have not done that, So these kind of tools, when you think about monitoring has always been like one of these, oh, I don't want to do monitoring. Monitoring is so much work. But monitoring is it's one of the cornerstones of your operation. You can't really start doing any of the other things unless you have monitoring to back it up. Because when you're talking about, oh, I'm going to add a new machine or remove it, these are actually not just operational decisions. These are also business decisions. So you need to be able to go, we need this because of X and Y, right? I want my application to be up and running. So, as a sysadmin or a DevOps, I want my thing to run. But also my manager is going to go, hang on a minute. Why are we spending hundreds of thousands of dollars on hardware? Do we actually need this? Can we do something better? And you need the metrics both for yourself and for your managers. So then you need automation. And this is something we started doing at Orchestra. You need to plug into your monitoring. And this is where you start being able to take that data, that monitoring data, have something automated that takes the data and figures out, oh, shit, you have loads, right? And then, OK, that means we need a new API server. Boom. It tells the load balancer, all right, here's a new API server that I booted up. And it just happens. And it's great to kind of have that ability, because then you can actually go out partying at 4 a.m. and not get a phone call telling you, oh shit, everything is down, and you're like on your iPhone drunk in a club. Okay, I'm SSHing into the box, man. That's probably happened to more than a few people in here, where you're actually, it's a Friday, it's a Saturday, it's 3 in the morning, or you're still in bed or whatever, and it's just like you get a phone call. Shit, something went wrong. What went wrong? We don't know. Go find out. So that's where the monitoring is so essential, because you can either automate it, or it can start telling you, it can start emailing you, oh shit, something's happening. And then you can go on your phone and do something fancy. But if you bring them together, it is really cool. So for example, in Orchestra, we decided we wanted to bring these things together. So we're actually making servers automatically spin up. We spin up new web servers automatically when the load goes up. And when the load goes down, we have a cooldown period. So if the CPU goes over 70% for like a minute, we'll spin up 2 new servers, micros, right? And we'll boot everything up, and it takes like a minute and a half to boot it up. So we're priming up 2 new servers to be able to handle specific loads, right? And if the CPU goes down below 30% for a whole minute, we will take 1 server down. So we're actually just automatically making the infrastructure handle itself. So we're sitting there. Occasionally something goes wrong and we have to look into it. But for the most part, it is kind of smart. It's like you can add some intelligence into your infrastructure. Sometimes it's so efficient that it's scary. And you just need to make sure it doesn't turn into Skynet, right? Seriously, we sometimes just see things happen. And we go, oh, someone, we do this for customers. So we got a big customer the other day coming in. And they were just trying things out. And then they put it live. Somewhere in, I think, Spain, political campaign. And something was wrong. But that was like 3 weeks into their application being deployed. And we looked into it, and we were like, oh, OK, so there's a broken server there that wasn't correctly handled because the monitoring didn't account for that case. Then we looked at what had happened over these 3 weeks. They had spun up 200 new servers, but also spun them down. So we had been adding and removing 200 different servers over the course of 3 weeks because they got, you know, an influx of traffic one day. Then it was like, you know, nothing happened. And then, you know, 5 o'clock when the ad came on TV again. And it just chugged along. No one had to do anything. And it's really nice when you end up in a situation like that. So high availability. I'm going to go a little bit fast now because we have 10 minutes, since it only gave me a 45-minute slot. If you follow some of these examples, you'll end up with a fairly resilient setup. Why? Because you have monitoring in place, you have the load balancing. Like you can add things and remove things, and if something is broken, you just yank it out of the chain and you add something new that's better. But even Google has outages. I think only a few months ago, things were down, like the Gmail was down for like 24 hours or more. So what to avoid if you're building a PHP application and you're going to the cloud, or more so, you're going for the decoupled setup, you need to start thinking differently. You need to start thinking, my server can go away at any second. This is not a constant. It's not always there. It might be there 1 second, gone another second, and back another second. Why? It's just the whole elastic behavior of, you know, shutting things down and bringing them up. So what to avoid? You need to avoid local sessions. Instead, store them in a database or memcache. Why? If the server goes away, that means the session that the user had on that specific box is just gone. Local memory, for the same reason, unless you're willing to lose memory, as in you're storing something, you're processing something in memory, are you willing for that box just to go away and losing that information? Probably not. Again, you can use network memcache or Redis or something, you know, something that's a bit more persistent, something that's not on the box itself. Again, local files, anything that's local, basically. You need to avoid that. Local uploads, writing to a temp directory. If you're not willing to lose that information, you need to start thinking, all right, I need to store this in S3, you know, I need to store this in a separate location from my web servers. Obviously, that is if you're building a setup that's kind of fleeting like that, you know, things are coming in and out every second. So the solution is to use S3 or a networked FS, like NFS, cluster, those kind of solutions. You had a question?
Sorry.
Oh. I have a question for myself. Oh.
About cluster, is it actually fast enough to serve PHP files or images?
Cluster? Yeah, it should be. So there's obviously going to be eventually consistent behavior. So it's the same as with S3. If you upload a file to S3 and then you try to hit it immediately afterwards, it may or may not be there right afterwards. It's just because like they're writing it to disk and they're, you know, they won't be able to serve it up right away. So Gluster has been improving a lot lately. Gluster is just a distributed file system built on top of your local file system. So it's actually not a new file system as in locally. You're still using X4, X3, ButterFS, XFS, you know, that kind of stuff. So it just builds on top of it. And Red Hat just released really recently a new version that's better for virtual appliances. So it's pretty cool. We've used that a little bit internally thus far. We actually are, so one of the biggest problems when you're building any kind of setup like this, or specifically platform as a service, it's the file systems. So if you're building a Ruby platform as a service, people have been kind of massaged into not writing stuff locally. But most PHP people assume they have a file system. They just assume it, which is kind of like, we haven't really trained people out of the mindset of not doing that. So we started out, and we actually tried to use S3 as a file system, right? Pretty brave. And that kind of fell on his head thing. It was like, it worked but didn't work, and then we started playing around with GlusterFS. GlusterFS has its own problems, but Unfortunately, I haven't been on that team that's actually dealing with that, but from what I've heard, it's good if you're willing to keep an extra box somewhere that's like the mediator. Like if you're trying to make a setup that's just your web servers that talk to one another and make things happen, Gluster is not as good. But if you have like the arbiter box that goes, all the files are there, you know, I got a new file, everyone update, blah. So it's a hard problem to solve, basically. Huh? Yeah, it is a point of failure. But you can also, if you realize that, you know, when you get into the distributed world, everything is usually, or mostly, eventually consistent, then it's not a failure. It's just a thing in there that you need to account for. So it's like saying, oh, PHP is not that amazing on, you know, the command line. Okay, is that a failure? No, it's just something you need to work around. So it depends on how you look at it. So in our case, we do consider that a failure, in fairness. But that's because that's a business problem for us. I think it still is. It's the case with any file system these days. Bigger files are easier for the file system to handle because of the block, or actually it's more to do with the hard drives. It's the blocks on the hard drives and the defragmentation and all that stuff. So it's even worse when you deal with network on top of that. It's because of the size of the TCP, how much one TCP packet, the size of it. So. It is, yeah. Basically, his answer is that he ended up not doing Gluster and all that stuff. And this is one of the biggest problems when you're dealing with a distributed setup. How are you going to deal with it? Hadoop had to make their own HDAFS or whatever it's called to deal with the distributed nature. What's it called? HD? HDFS, yeah. So it's a big problem. So going on from there, since we have even less time, serving up static files from CDNs, and thinking, like, just remembering servers can vanish at any given time. This is a really hard concept for a lot of people to grasp. It's like, my server is there, I can log into it through SSH, but suddenly it's gone? What's that? So you have to start thinking differently. You can start doing internal APIs, just a few simple diagrams. You can start doing things like, you know, I'm going to have an internal storage API where, you know, the file system S3 and GFS or whatever is hidden behind, which means that if you create your own abstraction on top of that, or use streams or something that allows you to kind of, you know, abstract that away, it means that you can start introducing different aspects to the operations without the application realizing, oh, you decided to move away from, you know, the file system to using S3. It's a great way for one application that I developed was, it was mostly built on S3, but when I was developing locally or I was on a plane, I don't have access to S3, you know, I don't have internet. So we created the internal storage API to abstract that away and go, all right, when I'm in development mode, I'll write to the file system. The same when you're dealing with APIs. One of my previous companies that I had, we started out with MySQL. Just plain MySQL, and we had an internal database API that we called. That was just a database API, and said, give me that record, make that happen, blah, blah. It was kind of like a lame ORM almost. But then we had to add in a caching layer, no problem. The application didn't have to do anything. It was just that discrete part that a small team implemented. And then we decided, let's add Mongo for specific things. So logs and stuff like that went into Mongo, and relational data went into MySQL. So it gives you the ability to kind of hide things from everyone else, even your own teammates. It's taking away the issues for them. So, fuck it, I'm just going to run over. All right, Gearman. Let's talk specifically about Gearman, because Gearman is a really interesting tool. Gearman allows you to fan out tasks to other servers. So you have a manager that says, hey, I have these specific tasks. Are there any workers out there that can do this? by that, I mean the job server here. So you have your client code, and let's say you have a worker here that's specifically tuned to making images, taking image data and processing it and going, oh, that's a penis. We can't put that online. Or, oh, this is a cat, so it should go into the cat section. Or I need to resize the images. So you can fan out work, and you write your own kind of code that says, here's the job, make this happen. The job server goes and sends out a command to the workers, and you write your own worker code as well. So this is like an API for the job server where you create code on top and on the bottom. You can get a really cool client worker library at pair.php.net/net_gearman. I'm going to just tell a really quick story, and then we're done. And it's going to be a story about why I love Gearman, and why it's such a simple tool, yet it tells you why distributed architecture can save your life. Not save your life, but it can help you. So I used to have a client for a year and a half, a financial software. We were doing bookkeeping. We were dealing with one of the clients of that financial software was McDonald's in the Netherlands. So not just them, but pharmaceutical companies and many other things. So we had their invoices, we had data from their POS system, point of sale systems, and all that. And we had to make something cool happen, like graphs and diagrams, and make all the pointy hair bosses go, yeah, we're awesome. So we had 3,000 plus clients on that system, and it was really data heavy. We had, I think we had 200 million records in one table in MySQL at one point. I'm not sure how we did it, but somehow I managed. So we had, and we kept processing in at least 500,000 new records a day into the system. But we used to do all that stuff on the fly. So like, oh, let's create the diagram on the fly with all the complex SQL queries. That wasn't working out too great. So all these clients, they will have their external data sources. Some of them will have, plug into that system. Another person will plug into that system. But all of them will plug into multiple systems. So all of them are data services as well, web services. So we had to make something that runs a cron job every 6 hours, fetches stuff from there, and does something with it and saves it. And when you're dealing with sending a lot of queries over the web and dealing with the data that comes back, it is a mess. So we had to make something really efficient, and we did that in Gearman. Yeah, ran every 6 hours a day. And this is kind of the structure of that. This is what I came up with eventually. So we have cron that kicks off a Gearman kind of like, oh, everyone go do that. And we have just workers running on different servers, and a job manager or a job server that will go, all right, I got all these 10,000 new jobs. Who's available to make that happen? And we have maybe 500 different workers, and all of them go, me, 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 me. And then, it fans out the jobs slowly. And whenever a worker is done, it will go, I'm available. Do you have anything for me? And then, you give out the job. So job number 1, fetch data from the web service, right? And that was a single job. That was a single Gearman job. But within the Gearman job, it had the knowledge that it needed to go to all these different web services. And then, because of how Gearman is built, if you think about MapReduce, a worker in itself, they can kick off jobs for other workers. So it can actually go in here and say, hey, I got data from the web service. Someone has to process this. All right, that means that I need to put a processing job in the queue for this data. So the processing, so we have 2 different workers happening there. We have the processing workers, and we have the web service workers. So what the processing workers do is that they take the data and then make it into kind of a cached format, kind of like they massage the data and go like, oh yeah, this is awesome. We can use this on the website. And they save the data. They save the raw data in the database. They save the processed data in the database. And they prime the caches as well, which meant that our software started working a lot faster. So this all happened in the background. through the virtue of gearman, which is great. But as account managers are a bit kind of, they always want to see the latest information right away. They hate waiting 6 hours for updated information. So they wanted to have this. They wanted to actually make it so when you log in, we would start hitting the web services right away. And when the login request was done, supposedly all the data was supposed to be up to date. The biggest problem with that is that cron job. It took it 6 hours to run, the full cron job. So we constantly kept crunching through data. And so I was sitting there. So when you log in, you want me to fetch the data that takes 6 hours to deal with and make that work within the confines of your user? And the answer was yes. How do we do that? So I sat down and I realized, well, I don't have to process 3,000 clients when I log in. What I'll do is I'll kick off the job when they log in only for their companies, only for their clients. And sometimes those are managers of a single McDonald's outlet, right? So it meant that I had the ability to go the same way as the cron, but I would go, all right, just kick off the job only for this client, and it would take a fraction of the time. And so they had up-to-date information almost instantly after login, and it allowed me, the infrastructure that I built up there, it allowed me to adapt to a situation within minutes. Why? Because it's built in a distributed fashion. It is built with the mindset of what happens if someone comes in with a crazy request. Am I going to have to change my system completely? And the last one is for gearman to make sure that gearman stays alive or any kind of distributed service. You can use supervisor D. And a friend of mine wrote a really good blog post about it. I'll publish all of these online if you don't want to write down the URL. But what it does is it's the daemon on your box that making sure that other daemons stay alive and have the right amount of workers running. So basically, if you say Nginx, you need to stay alive, you can make this guy make sure that Nginx never dies. And if it dies, it kicks it off in a specific way. You can use it for gearman. You can use it for a lot of different things. So when you're dealing with a distributed world and you don't want to be logging into boxes all the time and going, is that service up and running? You'd rather just employ a different infrastructure that runs on the boxes that makes sure everything runs. It's really warm in here, isn't it? All right, it's just this one and another slide and then we're done, I promise. So these things are really good, like building a queuing system like gearman or other similar systems. They're really good for image processing, distributed logs, data mining, mass emails, because we all want to be spammers, right? And intensive transformations and search. So in my example, I was doing data mining and intensive transformation in that small story that I told there. But you can do image processing, or you can use gearman, where you have your servers send stuff through syslog to a gearman worker, or to a gearman boss, basically, or a job server, and go, here's my syslog data, here's my log data for Nginx. You need to save it somewhere, but I don't want to be spending time or resources on the actual box to be saving it somewhere. So you can cheat it by actually using gearman to kind of process that in the same way where you're data mining your own logs and creating some sort of pretty charts for like the managers. So it is a simple tool that can do a lot of cool things. Any queuing system can do this. Here's just a few common tools that I've used through the years. Gearman, Hadoop, ZeroMQ, and RabbitMQ to achieve these things. Some are more complex than others. Some are more suited to specific jobs than others. Unfortunately, I don't have time to explain all that. I had a big section about the CAP theorem as well, but when I realized we didn't have time, I took it out. So CAP, the CAP theorem, or the Brewer's theorem. I recommend that all of you look that up, because it is quite important for any kind of distributed setup. And it also explains, in many ways, why databases work the way they work and some other ways. So, any questions? No? Yes? Everyone dazzled? Tired? All right. Thank you.